Hi everyone. In this video, I will explain 4.2 graph of basic functions of Math 111. This is for طلاب وطالبات السنة التحضيرية قسم العلوم بجامعة الإمام عبد الرحمن بن فيصل بالدمام. Okay, so we will learn in this section how can we recognize a specific types of functions by their graph and how can we classify the basic functions. Okay, so recognize and classify a specific function. The first type that we're going to talk about is the constant function. So this is the first type, is the constant functions, الدالة الثابتة. And this is the form of the basic functions of the constant functions. F of x equals c, where c is a real number, يعني عدد ثابت. So c here is a real number. So an example of that, y equal 1, y equal 3, or instead of y, since we are talking about function here, so we will write f of x. So f of x equal 1 or f of x equal 3. This means that for any values of x, we will have only one value of y. So the image of x, whatever x it is, the image would be c, or 1, for example, or 3, or whatever. So as you can see, when we graph those points, we will have a point that is located on the same level. And when we connect them, we're going to have a horizontal line, okay? So this horizontal line passes through all the points x and c, where x has any values on the real numbers. So for this graph, we can find out the domain, and as we said, since the domain is the x component, so we can see that this is continuous from both sides, so it would be from negative infinity to plus infinity. But for the range, since the range is only the y component, so we can see that the graph intersect y-axis in only one point, and exactly one point, which is c. Okay, so the intersections of the graph with the y-axis is c, so this is the only values of the y component, so this is the range. Okay, the second types of the functions is the identity function, and the identity functions is f of x equal x. Okay, so, or we can say y as a line, y equal x. So this is the function y equal x, or f of x equal x. It's that line divide the first quadrant and the third quadrant to two equal parts. And we can see that for any values of x, we will have the same values of y. Okay, also for any values of x, if x equal negative 1, y also would be negative 1. If x equals 0, y will equal 0, and so on. So we're going to plot those points, which is negative 2 and negative 2, then negative 1 and negative 1, 0 and 0. So we're going to plot all those points, then we connect those points. Okay, so the domain, as we see here, this is continuous from both sides, so it would be from negative infinity to plus infinity. For y also the same things, because this is not like it is in the middle, so it would take all the values of x and all the values of y as well, so the range also from negative infinity to plus infinity. Okay, so since the graph goes up as it following from the left to the right, as we said, if we are taking this direction from the left to the right, we can see that the graph is going up. So the f here is increasing on the domain, or on its domain. The third type of function is the square function. Okay, and this is the form of the square function, f of x equal x squared, and we want to graph it, we will have this graph. Okay, so for any values of x, the value of y is the square value of x. So y take any values of x and square it. So negative 2 square equal 4. Negative 1 square equal 1 and so on. So the domain بما انه الخط هذا مايل يعني راح ياخذ الاكس كل قيم الاكس وكل قيم الواي at the same time. So from this side it would be from negative infinity. And from this side it would be also to the infinity. While in the range, which is the y values, we can see there is nothing over here. يعني ما عندنا graph تحت. So that's why the value of y starts at this point, which is 0 to infinity. Okay, to infinity because it's going up to the infinite. Okay, so to decide whether the graph is decreasing or increasing, or whether the function is decreasing or increasing, we can see in the function here that it takes two directions. In the beginning it's going down, then it's going up. So in the first interval from negative infinity to 0, the function is decreasing. And in this interval from 0 to infinity, the function is increasing. Okay, now if we want to determine also whether the function is decreasing, is even function or odd function, we have to try f of negative 2, negative x, f of negative x. And we want to see whether this equal f of x or equal negative of x or neither one. So if you want, when we just find out f of negative x, which means to apply the rule of the function. The rule of the function, take any values of x and square it. So we get a square negative x squared. So we're going to have x squared, which equal f of x. So we start with the f of negative x and end with f of x. So that's why f is an even function. The third type of function is the cube function. And we can draw that cube functions like this, as you can see. Cubic functions are the rule of the function, it takes any values of x and cube it. So the negative 2 to the power 3 equal negative 8. And since the power is odd, so the negative will remain. As you can see, the negative is remain, then we will cube the 1. So 1 cube equal 1 and so on. So we just found out 5 values of points. The first one is negative 2 and negative 8. The second one is negative 1 and negative 1. Then we have 0 and 0. Then we have 1 and 1. Then we have 2 and 8. So we plot all those points on the x-axis على المحور, and then we connect them. Okay, so now let's see whether this function, what is the domain and the range of this function. The domain of this function, as we said, this is not like horizontal or vertical, so it takes both direction, يعني مايل. So it takes from negative infinity of the y values and also of the x values. So it's from negative infinity to also here plus infinity, and for y the same things, negative infinity to plus infinity. The graph here, as you can see, if we go from the left to the right, we can see that the graph is going up. The graph is going up, so it is increasing. Okay, is it odd function or even function? So we have to calculate f of negative x. So just use this formula and replace each x with negative x. So negative x to the power 3. Now, since this is odd, so the negative will remain x to the power 3. And we know that this one is f of x, so negative f of x. So we start with a value that f of negative x, and we end up with negative f of x. So this give us the or satisfied the condition of the odd function. So it is an odd function. Okay. Then we have another basic function, which is the square root function. So f of x equals the square root of x. And this is the square root of x. This one is the drawing or the graph of f of x equals the square root of x. So the same things, we will just we will just like put any random values of x, maybe 0, 1, 4, 9, 16. So those values are the values from your choice. Then you calculate these values by using the function rule. So the function rule takes any values of x and square it. So this would be square root of 0, here square root of 1, square root of 4, square root of 9, square root of 16. So when you choose the value of x, make sure to choose the value that makes the calculation easier. Okay, so the values or the point you have here is 0 and 0, 1 and 1, 4 and 2, and so on. So we just plot those points on the x-axis, then we connect them to have the graph. Now, what is the domain and the range for this function? So for this function, we can see that we don't have any things on the x negative side of x. Okay, so there is no graph over here. Also, we don't have any graph in the bottom of y-axis, which means that the values will start at this point, which is 0 and 0, and it continues to the infinity. So from 0 to infinity, and also the range from 0 to infinity. And we can see that this graph is going up for in all the domain. So it is an increasing function on the domain. Okay, this is another type of base of an equations or of an function. F of x equal the third root of x, and this is the graph of the third root of x. So look like this. And we can just, as we said, set up points of x from our choice, and then calculate calculate by using the formula or the rule that we have of x, the definition of f of x. So f of negative 8, so we just get to replace x with negative 8, which means the third root of negative 8, which equal the negative will be out, no problem, because this is an odd. Then the third root of 8 is 2. And so on. So the first point would be negative 8 with negative 2. The second point, negative 1 with negative 1. And we have also 0 and 0, 1 and 1, and 8 and 2. So we will get to plot those points on the number line, and then we connect them to get the answer. Okay, now to find out the domain and the range, as we said, for the domain, we're going to look at the x values. And if you can notice here that also we have this line, it is in the middle in between the x and y, which means it takes infinite values of x and also infinite values of y. So the domain will start from negative infinity, and the same things over here is in between these two. So it's going to take infinite values of y and infinite values of x as well. Okay, and obviously you can notice that it is increasing from the beginning to the end. Okay, it's going up from the left to the right, so it is increasing on the domain. Okay, is it odd or even function? Of course, it is odd because when we calculate f of negative x and replace x with negative x, then the negative will stay outside, then we have the third root of x, and this is just f of x. So yeah, it is an odd function. Okay, also we have the absolute value function. Okay, and this is the graph of the absolute value function. We can also set a values of x, then we calculate the value of y, we plot the point, and then we connect them together. This line again, to find out the domain and the range, we can see that this line takes infinite values of y and also infinite value of x. The same things for this line, takes infinite values of y and infinite values of x. So the domain would be, for this one, it will take, yes, infinite values of y. Okay, so for the range here, we can see that there is no values in the bottom of y's. Okay, so it's a start exactly at this point, then to plus infinity. But for the domain, it starts from negative infinity to plus infinity. Again, the domain is the x component while the range is y component. So we can see that y starts at this point, which is 0 to the infinity. Okay, is it decreasing or increasing? We can see that this graph has two directions. In the beginning, it was decreasing, then it is increasing. So it's decreasing from negative infinity to 0 and increasing from 0 to infinity. Okay, we have the piecewise function or piecewise defined functions where we have two definitions or more of the same function. This is an example of a piecewise functions. It says that we have x squared for the interval from negative infinity to 0. Then we have the definition x plus 1 when x is positive. Okay, so this is the absolute values function is also one kind of the piecewise functions because it has two definitions. It is x when x is positive and negative x when x is negative. So yeah, again, we have many types of piecewise functions. When you see more than one definition of the function, it is a piecewise defined function. Okay, so if we got some values of f and then we have f of x, which is this one. So the question over here is that to find out what is those values, what is f of negative 3. So f of negative 3, okay, we replace each x with 3. Now, usually we have one definition, so we don't have any problem, but here we have to think whether you substitute the values in the first definition or in the second definition. So it depends on the values of x. Here we have a negative value, so this is negative and this is positive. So since this is negative, we're gonna use this definition, which is x squared. So we will take the value and square it, then we will get 9. Okay, now f of 0, okay, since 0, we go into substitute the value in this definition because here we have the equal sign, okay, and then we will substitute the values in the definition, so 0 plus 1, which equal 1. And for 2, the same things, we're going to use the second definition because 2 is located in this interval, so 2 plus 1 equal 3. Okay, so same things, we have this exercise for the following piecewise functions. We'll find out f of negative 4. So for the negative 4, we have to decide, this is like in the number line I have negative 1. So when x less than -1, I'm going to use this definition. When x more than or equal -1, I'm going to use this definition. Okay, so now let's try that. F of -4, it means a -4 is located over here. So I'm gonna use this definition. So f of -4 equal -4 to the power 3, which equal negative, then 4 to the power 3, and 4 to the power 3 is 64, so -64. Now what is f of 0? 0 is located over here. So I'm gonna use this definition. So 0 square, which is 0. Also f of -1. -1 is located over here. So either we can use the first definition or the second definition. But be careful. The question tell you where to use it because of this equivalent. Okay, المساواة موجودة هنا. So we gotta use this definition. X square, so -1 to the power square equal 1. The last one is f of 3, and the 3 is located over here, so we gotta just square it, which equal 9. Okay, so piecewise defined functions. So to sketch this kind of function, we have to sketch the graph of f of x first, then we sketch the graph of y equal x squared and y equal x plus 1 separately. So since we have here more than one definition of the function, we're going to sketch this one first, then this one. So we gotta sketch them separately. So as you can see over here, we have x squared. You know already what is x squared. This is x squared. اوكي من خلال نفس الدرس احنا اخذنا بعض المشهورة الفانكشنز المشهورة مثل x squared. So this is the graph of x squared. Now x plus 1, you know y equal x, it is in the middle like this, and the plus 1, that means I'm going up 1, then I will draw my graph. Okay. So I have two graph. I draw both graph. Now which part should I take? So for the first one, I will take x less than or equal 0, which means the negative side. So I'm just going to include this side in my graph. And for this one, I'm going to use the positive side. So, okay, so the positive side means from here to here. And for this one, I'm going to use only the negative side, which is from here to here. So we're going to draw this two parts over here. Okay, and it would be something like this. Now the open point at 0 and 1 here, as you can see, we have a point, an open point, and this means that this point is not part of the line. Okay, so when we make a hole, it means we don't want to include this in this line. Okay, and the close point, which is this one, means that the point 0 and 0 is a part of the curve. Okay, sketch the graph of the piecewise function. So as we said, we gotta sketch each one separately. Okay, so I'm gonna sketch the first one, then I'm going to sketch the second one, then we will combine them both. So for x to the power 3, if you remember here, we already talked about the function y equal, or f of x equal x to the power 3, which is this one. Okay, so to sketch this one, okay, and then x squared, which is this one. Okay, now this is in all r, but I don't want in all r. I want just here x less than -1. So from negative infinity to -1. Okay, and here from -1 to infinity. Okay, so I'm gonna include this part from -1, which is here. So this part, okay. So I'm going to include this part. Let's see, where is -1? Here is -1. So starting from this point to the end, and also I'm gonna here is -1. So the same things with the other graph, it's from -1 to infinity. So from -1 to infinity. Now to combine those two together, so we have to draw the first one, then we draw the second one. Okay. Okay. Now, which one we will put a circle or a dot or an open circle, and which one we're gonna put a closed circle? So in this graph, it would be a whole because we don't have the equal sign, and here, since we have the equal sign, we will make it fill. Okay. So this is the graph of this function. That's all for this part. Thank you for watching.